Speaks, and we're going to continue matrix part 2. This is a continuation of the first part of matrix, so if you have not watched the first part of matrix, please do so before you watch this video, because we are going to talk about multiplication in this video, and it will be a bit more complicated if you do not firstly understand the introduction of matrix. So if you still can remember from the first part of matrix, the size of the matrix is determined by how many rows and how many columns the matrix have. So for the first matrix on the left side, the size will be 2 by 2 because it contains 2 rows and 2 columns. Whereas for the matrix on the right side, it will be 2 by 3 because it contains 2 rows and 3 columns. Now, if you want to do multiplication here, we are talking about multiplication. Okay? You must ensure that the matrices have the same value for this part here. Meaning to say, the column for the first matrix or for the matrix on the left side must be the same as the row for the matrix on the right side. Okay, so positioning is important, because if you switch the position, then it's different and you cannot do multiplication anymore. Okay, and therefore, if they are the same, you can actually do multiplication, and the answer that you will obtain, or the size of the matrix, will actually be 2 by 3, because the answer here will be the remaining value of the size of the matrices. Okay, weird as it seems, but it is actually how it works. So let's take a look at one example. Okay, we have two matrices here, matrix A and matrix B. Let's look at the sizes first. Matrix A will be a 2 by 1 size, and matrix B will be a 1 by 3 size. So checking whether they have the same value or not for the sizes, yes, they do. 1 equals to 1, and your answer here will be 2 by 3. Okay, so that is something that we can put in mind. So how do we do the multiplication? Simply put them side by side, because you want to have a multiply by b. So each of the elements will multiply by the respective corresponding elements once, and giving you this matrix here. So remember, multiply them 1 by 1, just like how you would expand multiplication between brackets and numbers. So simply simplify this matrix here, and there you go. You have matrix A multiplied by B will give you 2, 0, 3, and 0, 0, 0, because I happen to have so many zeros. Okay, what if it is the other way round? What if I want to find matrix B multiplied by matrix A? Is it possible? So if you look back, matrix B is actually 1 by 3, okay, and matrix A is 2 by 1. So you're going to put back the sizes here, and unfortunately the 3 is not equivalent to 2, so therefore the multiplication of BA cannot be done. Moving on to example 2. So now we are going to see two matrices A and B, and each of the sizes is 2 by 2. So how are we going to do the multiplication for these matrices? We are going to write them side by side as usual, because it's multiplication. So we start off by looking at the row of matrix A and the column of matrix B. So each individual elements of the matrices will have equal chances to be multiplied and added. You repeat the same steps for each element, and you will end up getting a 2 by 2 matrix as well for the end product. So I hope you have learned something on matrix multiplication. See you again soon. Bye bye.